Hello, we're Team Medical Compute using ChRIS on MOC. This is video for our final presentation. So these are the contents we'll be covering today. So first things first, let's briefly talk about what is ChRIS. ChRIS is an open source platform for medical analysis with an access to the GPU-enabled hardware on OpenShift. ChRIS can show the plethora of possibilities. But why do we need it? What's so special about the ChRIS? Out in the world, we have a lot of innovative and useful technologies. Not surprisingly, medical field hasn't taken any benefits out of it. Let's put it outdated. While the field directly connected to the core values of human life. Therefore, ChRIS introduces the advanced technologies such as cloud computing and image analysis to clinicians and researchers on the medical field. Here we have a part of the architectures of ChRIS and its connected services and platforms. You can see the ChRIS and the MOC Docker Hub is connected. Using services on the back end, it executes the user requested app on MOC, and these apps is built in a Docker image. So far, our user story we have is, as a ChRIS developer or administrator, I would like to have a way to test how my plugin performs on different architectures such as x86-64 versus PowerPC. Therefore, I want a ChRIS plugin that performs a benchmarking test on these architectures. This user story leads to our goals for this project, which is developing the benchmarking app that compares a performance difference on different platform architectures. To be more specific, we're developing benchmarking plugins for x86 and PowerPC. Why do we need PowerPC? This is for a greater GPU performance. As you can see in the feed graph we have in the slide, we'll be building a one single node, which is the equivalent of app on MOC, ChRIS platform. For scope and features, the benchmarking plugins should provide a series of tools to test the performance of the system and represent the real workloads that may be deployed on the system. On top of that, test functions should be small size and estimate the time that may be spent on running real computing tasks.
Okay, so then I'm gonna show you our project accomplishment so far. So basically, as our in our MVP, so we already successfully built these 4 Docker images, which are matrix multiplication for both x86 and PowerPC, and also the object detection plugins for x86 and PowerPC. And apart from that, we've also successfully built and deployed these PMAN and PFLH images for PowerPC version on MOC. And these 2 images are currently available to the other Austin Children's Hospital team. And okay, so looking at this ChRIS workflow picture here, so we actually have almost touched almost every part of that workflow. So for the stored part, our Docker images are currently maintained under the Docker Hub FNDSD repository. And for the ChRIS part, we've already tested our ChRIS plugins through the ChRIS GUI and also the command line interface. And also, as I mentioned before, we've also deployed these PMAN and PFLH containers running on MOC. And then I'm going to show you matrix multiplication plugins, and I'm going to show you like how it runs through this ChRIS GUI. So first, in order to like run your ChRIS plugins, so you have to like create a new feed. And after you assign a name and upload the input files you needed for your plugins. And then there you go, you have your first node in the ChRIS workflow tree. And if you have to like upload some files, it might take some time, and we'll skip that part. And when it's done, you can see there's data files that includes all your files needed for that. And then we can like create our own plugin node, which is matrix multiplication. And when you have already assigned the parameters you need for that plugins, so it is running now. We also like skip the computation part. It also takes some time. And when it's done, you can see we have this output file, which is multiply record.csv file. And also, if you look at the other JSON files, they will like provide you some extra information for the workflow.
This time, I'm going to introduce you the object detection plugin for Power 9 cluster. Yeah. So you can see we're using the command line interface to run this plugin. And firstly, it will download some essential files and then build the TensorFlow engine. Yeah, that you can see it got started. And it will print out the information, the result of every frame, like in inverse time or detection result. And after it finishes all these steps, it will output a conclusion file and output.avi, which is output video after the object detection. Okay, so that's our benchmarking result. The first paragraph shows the result of x86 platform, and the second one is result of Power 9. So you can say it's pretty similar. We guess that because the GPU chip on both platforms is pretty similar. So the performance for this test is quite similar. And for object detection, yeah, you can say the inference time in different platform is quite different. Power 9 machine, the typical inference time for each frame is about 4 microseconds. However, in x86 machine, we got 6 to 7 microsecond inference time for every frame. We think the difference is significant. As you can see, the Power 9 is a more approximately 40% faster than x86 machine. So overall, that's our milestones. Firstly, we developed ChRIS plugins for both x86 and the Power PC environments. That's object detection and matrix multiplexer. And then we deployed PMA and PIFIH on MOC, both for x86 and Power 9 cluster. And we run ChRIS plugins through ChRIS GUI and command line interface, as we just mentioned it. And we got microbranch result using our plugins. We just introduced it. However, although we finished all these stuff, we didn't finish our bonus task, that is run ChRIS plugins on PowerPC MOC clusters through pfcorn service. We will finish it as soon as possible.
And now we'll talk a little bit about what we learned for this semester. Firstly, talking a little bit about the technical things that we learned. All of us learned a lot about how to use Docker, how it works, especially to build containers and run them for our project. We also learned a lot about how to deploy containers to the MOC using OpenShift. And thirdly, we learned a lot about the concepts involving the ChRIS architecture and also how to build the ChRIS plugins that we built for our project. And then fourthly, we learned about GPU programming, specifically parallel computing and GPU memory structure. And lastly, we learned a lot about how to build PowerPC images in particular, because those were the images that we were really interested in building this semester. And now just to go into a little bit of detail about deploying PowerPC versions of PMAN and PFIOH on the MOC. So we were able to create the PFIOH, which is that file input output handler. We were able to create a Power9 plugin or a Power9 container of this function. And also we were able to create a PMAN, a process manager container in a Power9, so that it would be compatible with Power9 architecture. And those two are currently running on the MOC, and we're able to say hello to them as processes. However, as Hao Young has talked about earlier, we haven't been able to run our plugins on those instances of PFIOH and PMAN, and that's kind of a future plan. And then we're also talking about some non-technical things that we learned this semester. First, us as a team, we learned a lot about the Scrum team concept, particularly the bi-weekly sprints and having to stay on top of deadlines for that. We also learned, because our project was big and there was a lot of different elements to it, we learned about how to manage and distribute those tasks, especially using Taiga as an application to do that. And then thirdly, and probably one of the most important things we learned is when we had a technical challenge, maybe an error or something like that, being able to communicate effectively with our mentor to kind of explain the problem and the environment of basically how we encountered that error. Because if we just explain the error, that's not giving much context. So learning how to effectively communicate in a technical setting to other team members is super important, and we learned a lot about that this semester.
Now we want to talk a little bit about our limitation and our future plans. So one apparent limitation we have for our product is that our benchmarking purpose is too general. In other words, the plugin we developed does not fit every use case. For ChRIS developers, some of those may concern about the memory operations most, but others may concern about something completely different. So that's one thing to do it. Another thing we should improve is that our plugin is only supporting the GPU number of 1 now, and that's apparently a limitation, and we're going to improve that in the future. So for our future plans, firstly, we are thinking expanding our product to be more adaptive with more specific parameter options. For different usage of benchmarking purpose, we will provide with different tools to test. Also, of course, we will just improve what we just said, the GPU number limitation in the future. The third one, finally, Red Hat has started a project to fight COVID-19, and it is possibly to be developed on Power9 platform. Since our previous experience could help, it is part of our future plans as well. So this is all of our presentation. Thank you very much.